In this video, we're going to explore surface modeling and how you can use it to create incredibly complex designs with ease and take full advantage of the geometric freedom that 3D printing has to offer. Let's dive right in. In this video, I'll be using Autodesk Fusion, but many other CAD packages have powerful surface modeling tools such as SolidWorks, Onshape, FreeCAD, and many more, which means much of this tutorial will be applicable to those programs as well. The layout and such will just be different. Though I do need to clarify before we begin that the kind of surface modeling I'll be talking about is known as non-uniform rational B-splines, or NURBS. And it's very different to mesh-based surface modeling, which is made up of tessellated triangles or quads, and it's used heavily in video games because it's very efficient. And it's also the format we export for 3D printing. Either 3MF or STL files are made up of these tessellated triangles, and that means they have no true curves, unlike NURBS, which are actually true mathematically driven curvature, which is awesome if you're using parametric modeling because you can go back in your timeline, change things, and have your whole model update beautifully. You can navigate this video through the timestamps below, and a fair warning, surface modeling can be quite daunting if you're quite new to CAD modeling and you've only done sort of solid modeling before. So start at the beginning if you're a beginner, but if you have a solid modeling background, then feel free to skip forwards in the video as things get more and more advanced. But let's kick things off with the most important question. What is surface modeling and what makes it different? So what I have here is a surface, and you might think, well, that doesn't look too different to normal 3D modeling. What's the big deal? But if I turn it around, it is fundamentally different. It's like it's missing part of itself. If you ever downloaded a broken STL file, it might have looked similar to this. There's a lot of similarities because surfaces have zero thickness. They can't exist in the real world. So this shape, if I exported it and tried to 3D print it, the slicer won't know what to do. It can't actually fill it up. So surfaces and surface modeling are incredibly useful as a modeling tool, but you don't directly 3D print surfaces. That's because this surface is non-manifold or non-volumetric. You couldn't fill it up with water and have it hold that water. It would just leak straight out. And that's a really good way to sort of visualize the difference between surfaces and solid bodies. You have a sphere and you fill it with water, it would hold the water. That sphere would be able to 3D print because imagine your 3D printing is slicing it and knows that's a solid, I can make it a solid on a 3D printer. But with surfaces, because there's zero thickness, you need to make sure that if you're using them, that you end up combining them in such a way that they form a manifold, completely sealed, watertight mesh, or use them as part of the modeling process to cut away a solid object or modify in such a way that you end up with these volumetric shapes that can be reproduced. And that's one of the fundamental pitfalls that people fall into with surface modeling when they first start. They'll end up designing this amazing stuff because surface modeling is very freeing. There's very little limitations when you're using surfaces. But when it comes to actually reproducing in the real world, half the time it doesn't work because you haven't really considered that it needs to be made a volumetric object to actually reproduce. But if you can master surface modeling, then you'll unlock a whole new realm of design possibilities, which I hope to demonstrate in this video. So here we have a blank Fusion workspace, and by default, it's on the solid modeling tab. Now this is where most people will do the majority of their 3D modeling. It's where I do the majority of my modeling using solid modeling tools, but what we're going to be doing today is surface modeling. So right next to solid is the surface modeling workspace. And these tools, some of them might look familiar, some of them might look very foreign indeed. So let's step through them. We have extrude, revolve, sweep, loft, and then patch, ruled, offset. And then under modify, we've got these other ones like trim, untrim, extend, blah, blah, blah. Now, I'm not going to go through every surface modeling tool in this video. This is a starter's beginner's guide to surface modeling. But let me show you how they differ from the standard solid modeling tools you might be more familiar with. So let's start with surface extrude. So what I have here is a sketch of an arc. And this is not an enclosed profile. So normally when you're doing an extrude for solid geometry, it must be enclosed or it won't work. But with surfaces, because of zero thickness, you can do just lines, or in this case, a single arc. So I have my sketch, I'm going to do extrude, and then I can click that arc, and then I can just drag it out like that. and it creates a surface extrude. Alternatively, I could do a revolve. So again, just like the revolves for solid geometry, you want your profile and you want the revolve axis. So here I'm going to click revolve and I've got my arc as the profile, and we've got our axis here. And then there you go, it's a full 360 revolve, but I can do just 180 like that and say okay. And you'll notice that surfaces look like bits of objects where they're sort of missing parts of them. And that's kind of how you use them. It's one way you can use surfaces because they are zero thickness. On their own, they can't be reproduced in the real world, but they're very, very useful for creating geometry that then can be reproduced in the real world because it's solid geometry. Next is one of my personal favorites, which is a sweep. So a sweep will take a profile and sweep it along a curve. And sweeps are really, really powerful with surfaces because there's a lot less geometric limitations. They can intersect and do all sorts of crazy stuff and they won't fail. Now, that's not great practice, but you can get away with a lot more with a surface sweep than you could with a solid sweep. So here I've got my profile, again, the arc, and then I've got the swept curve here, which is just a spline. I can go to create sweep, and then I've got that arc, and then for the path, I've got that sweep there. And you can see you can create these really, really nice organic shapes really quickly with the surfaces. And last but certainly not least is a surface loft. So a loft takes two profiles separated by a certain distance and will blend smoothly between the two. So I'm going to go to create loft, and I'm going to select my arc, and then I've got this spline that's offset with a offset reference plane. And it's going to try to blend seamlessly between the two like that. And it creates this crazy organic shape. Now, you'll notice with surfaces, there's two different colors. You've got this sort of like steel color, which is a default material, and then you've got this ugly yellow color. In Fusion, this is denoting the direction of the normal of the surface. So surfaces have a direction. They face a direction. That's really important because it helps define the volumetric, the object that it's eventually going to form. So this is the reverse of the normal, and this is the direction the normal is facing out of. And sometimes you need to change it depending on how you're modeling. So to do that, you can go to modify, reverse normal, and say you want it to be facing the other way. I can select this surface, say okay, and it's flipped the normal. And you might be familiar with the term normals because it's often when you have a 3D printing file that's got errors, it's because it's got the normals facing the wrong way. And that means the slicer is having trouble determining the actual manifold object that it can then reproduce on your 3D printer. So same kind of idea with surfaces here and the mesh files that you work with 3D printing. Normals are very important. I will say within Fusion itself, it's quite resilient. It doesn't really seem to care till right at the end. But when it comes to exporting things, keep normals in mind. So to me, there are three main ways that you can take advantage of surface modeling for your 3D printing projects. Number one is to use these surfaces to cut up solids into multiple bodies. Now you might want to do this for assembly purposes to turn one object into multiples to assemble afterwards when you create them, or you might want to do it for multicolor or multi-material purposes as well. The second way you can use surfaces is to take those zero thickness surfaces and thicken them, which then turns them into solid geometry. And the third way to use surfaces is to combine separate surfaces to then create the outside of a volumetric solid body. And by actually combining them and stitching them together, you turn these zero thickness surfaces into a volume, which is manifold and then can be reproduced. So let's take a look at three example projects that use these three approaches to using surfaces for 3D modeling. And we'll start with this, a 2-color candy cane for 3D printing. Some of you may remember this project. I did this originally years ago in my original CAD for Newbies tutorial series when Fusion was a wee baby. But here it is, I'm bringing it back because multicolor has come along in leaps and bounds. More people are doing it than ever before, and using surfaces to cut up solid bodies for multicolor printing or even multi-material printing is incredibly powerful, and it's a skill you definitely should have. So how did I model this? Well, let's step back in the timeline and I'll show you what I did. To start with, I did a sweep. So this sweep is very simple. All I have is this little profile here. Now, I did cut the bottom of the circle slightly off because printing this flat on the print bed with just a cylindrical shape won't actually stick because you've got to think that first layer is going to be like zero contact area. So I cut just a little bit off to make sure that that first layer sticks just enough so there's not too much overhang. And then the path is a simple candy cane style shape. So the sweep then takes that profile and path and creates this solid body. And you can see here in the drop down, we've got one solid body there. Now to turn this solid body into two separate bodies that can be printed in two different colors, I used a surface sweep. But there's one little thing you can do within sweeps that's really powerful that I took advantage of, and that's twisting along the path. Here's how I created the surface sweep. So instead of the solid sweep function, I used the surface sweep. And instead of a circle, I just drew a line. And because it's going to be 0 thickness, a line is more than enough. For the path, I reused the same candy cane path that I used for the solid body, for the solid sweep. And you can see by default, it's creating this surface around the profile. Now, that would be a really boring looking candy cane, right? So what we actually want to do is we want to add some twists to this surface. And we can do that with twist angle. Now, what's really cool is you can change this to suit your liking. 360 along the whole path doesn't really twist very much, but what about like 1,500? Like that. Now that is really twisty, right? That is going pretty cool. And if I turn the original sweep back on, you can see that it would actually twist quite a lot along there. And you can imagine two different colors, it's gonna look quite good. Now you might be wondering, why is it extending beyond the original candy cane? Now I think it's good practice when you're using surface bodies to cut solid bodies to extend just a little bit past the solid body you intend to cut. If you do a surface right up, like perfectly, mathematically perfect to the edge of a surface, because it's twisting and changing and stuff, sometimes it means it might be a little bit wrong in some places and you'll get an error. There is an extend surfaces function in the split body tool that we're going to be using in a second, but here, because the candy cane wraps back around itself, it's not suitable. So good practice, I generally find, to make your surfaces stick out just a little bit to give yourself some room. Okay, I'm happy with this, so now we can move on to cutting the solid with our surface using the split body tool. You can find this within the solid or the surface workspace, but under surface, you can go to modify, scroll down to split body. And you can select the body you want to split, that's our candy cane, and then you have our splitting tool or tools. Now, a bit of, again, good practice. I find if you select the surfaces directly in the workspace, you can get a few weird glitchy errors. Like, look at this. Because this surface curves, it's been divided into faces. So if I just selected here, right, it's not selecting the whole swept surface. I actually want to select the whole thing. So easiest by far is just to select over on the left-hand side, the surface like that. And it will select every face of that surface. It's generally what I find. Good way to avoid missing anything. And we don't have extend splitting tools ticked. Now, sometimes it can help. Like you can see if I ticked it here, it actually would probably be fine. But sometimes it explodes and does things you don't want. So I find for best control, make sure you're just cutting where you want. But either way, this looks good. I'm going to say okay. And then I'm going to hide my surface. And just like that, we have a solid body cut into two bodies. Like that. Really neat. We can add some color. So let's go to appearance. And let's just chuck in color to one side, like that. And we can now export this as a mesh file, a 3MF, with two bodies within it for multicolor printing. The second way you might want to take advantages of surfaces is to use them to copy the surfaces of solid geometry and then thicken them into their own solid parts. Now, thickening surfaces is really handy for stuff like this. So here I've got the old CAD for Dead Cat Bounce. I am eventually working on a new one. It's very late, I am aware. But let's say with this robot, I want to add another panel that goes on the back that is like extra armor. So how can we model that cleanly and efficiently? Well, doing it with solid modeling tools would be quite difficult. You could do it with lots of Boolean intersections and such. But instead, what I'm going to do is I'm going to take advantage of the offset tool. So offset lets you grab any surface and you can either offset it by a certain amount, positively or negatively, or you can actually use it to copy surfaces, which is actually what I tend to use it more for. So when you select a surface, for example, I can click this face here, this face, and this one. Actually, I don't want that one. And then these ones at the bottom, like that. All right, if you find you're selecting faces you don't want, you can untick or tick change selection, or if you want to select everything, that's quite useful. And I have 0mm distance. So for example, if I change it to 3, you can see it's actually offsetting those faces into a brand new surface body, by 3 millimeters. But in this case, what I actually want to do is I want to make it a 0, which is just copying it. And if I hide the rest of the robot, you'll see that I've got this solid body now here. And this is a perfect copy of those faces, which means if we thicken this, we'll create a brand new solid body that will perfectly match those contours, which have been built up with heaps of features that we've done in the feature tree. To do that, you go to Create, Thicken, and then you select the surfaces you want to thicken, like that, and then you thicken them by a certain amount. Now you can thicken them outwards or inwards, or you can also thicken them symmetrically, a bit like the extrude command. But I want to thicken outwards from that face, and 3 millimeters looks quite good. And I'll do OK, and it's a new body. Sometimes if you want, you can actually join or even subtract, like cut away thickened surfaces from solid bodies, which is pretty advanced, but pretty powerful sometimes. But new body is what I want. And just like that, I've created this new solid body, which could be used as additional armor. Now, because of the way it thickens, it may expand outwards or retract, shrink inwards, depending on the curvature. So you might want to do some cleanup with the solid modeling tools. For example, it is intersecting with this area here. And I might actually want it to be flat at the top. I might want bolt holes, that sort of thing. That's when you come in with the solid modeling tools and modify that new solid body. But yeah, that is a really, really easy and powerful way of using surface modeling to add new solid geometry. And the third way you can use surfaces to form solid geometry is to stitch separate surfaces together to encompass a volumetric object and create a solid body that way. So what I have here is this crazy organic shape. And this is made up of lots of separate surfaces. To create the original surface though, I used a form in Fusion. And if you haven't used forms before and you've only ever done geometric modeling, I highly recommend giving it a go because it's a really powerful and parametric way of adding some nice curviness to your designs. In the form workspace, you can start with a primitive, or you can build up these objects, these NURB surfaces from faces, and then you can modify them by selecting edit form and grabbing like the vertices or the points, and then just moving them like this. Very nice and organic. And you can delete faces, you can modify them, you can add them, you can have symmetry. I've got a symmetrical line down the middle here. And you can see I've got a 0 thickness open surface, but you can also do a sphere or something like that and then modify it. And if it is fully enclosed when you finish your form, it will form a solid. But in this case, because it's open, it forms a surface body. And this was the resulting surface body from the form study. And you can see it's really nice, like curvature, but that bottom is not really flat. I want it to be flat to move on to other modeling tools. So what we're going to take advantage of is the trim command. So trimming and stitching are the bread and butter of creating solid bodies from surface bodies. You use the trim command with surface bodies, but you can also use it with simple sketches because it will create its own phantom surface, effectively filling in that role for you. And what I've got here is a flat line, this sketch. I'm going to use that to trim the bottom of my surface body. So I've got the trim command up here, modify trim, and I can select that line. You can see it's projected it out, extruded it out effectively into its own surface. And with trim, you just select the things you don't want. So I'm going to select the bottom here of that surface body. It goes red, and that means it's going to be deleted. And I say OK, and it's gone. Just like that. Really, really easy. And now the bottom of that surface body is nice and flat. But it's still not going to be a solid body, is it? Because it's open. It's wide open. So to cap off this hole, we need to patch it. Imagine you're patching a hole in drywall, right? Well, it's called patch. So let's go to Create, Patch. And a patch grabs a boundary edge. So let's select that edge there. And it will fill it in with a new surface that you can control in various ways. So by default, it's under connected. So it's going to be the most efficient path that the surface takes. But maybe you want it to be nice and curved and follow the curvature of that shape. Well, you can change how those different edges are treated. So you've got tangent and curvature. Now I prefer tangential. I find it's a bit nicer, but you can mess around with settings as much as you like. And you see now I've got that tangential relationship. It's got like that nice pillowy look, which is really, really cool. You can also control these surfaces with control curves, much like lofting, which is really, really neat, a bit more advanced. But yeah, you can actually get quite precise with these curves if you want to. I'll say okay. And it looks like we've got a solid body now, but we don't, because you can see one of those surfaces, the normals are facing the wrong way, and over here on the left-hand side, they're still not stitched together. So by default, Fusion will not stitch patches together to the shape that it's patching to. It won't stitch these surfaces together. You need to do it manually. So to do it manually, we have over here the stitch command. Now, again, good practice would be to reverse that normal. Sometimes you don't need to, but it is pretty good practice to make sure the normals are facing the way you want to. And then stitch, I can select the different surface bodies I want to stitch together. So I've got the top one and that bottom one. When it goes green, that means that edge is going to be nice and properly welded. Now, with the stitch command, you've got this tolerance slider. It can be really tempting to ramp this up if it's not succeeding, to try to make something stitch together. I would say that even though it can work, it can be bad practice and introduce more problems down the line. I recommend making sure your edges are nice and clean from the start and going back and fixing any problems if you can, rather than trying to use the stitch command to patch any holes and fill any weird mismatched edges of surfaces. Because it can happen, right? If that happens, I recommend trimming those edges away and then patching where they were, because you can get rid of any weird, horrible intersections that way. But I'm happy with that. I'm going to say okay. And just like that, we've converted two surface bodies into a solid body, like that. And fully parametric. We can go back to our original form and edit this. We can say, okay, I don't want the back to look a bit like a bum. I don't really want it to have that crease there. Let's pull that edge out like that. And maybe pull this edge a bit up, a bit more. So it's more rounded there. And more like that. Okay, maybe more like that. And I can say, okay, finish form. And as long as you don't change the faces so much that they no longer intersect with the areas they were before, there's a bit of wiggle room. The tools usually don't fail, and you can see it's updated perfectly fine. And then with just a few more features, I was able to add this flat piece at the top. That was a sketch that was then patched and then lofted to the outside of the area that was cut. Just a few more features you can add and add and add and create really, really unusual shapes. Once you get a bit more comfortable using surface modeling tools and combining them with solid modeling, you can do some really, really neat stuff that you just can't do with basic extrude and revolves and sweeps. Using surfaces to offset, cut, trim, patch areas really frees up so many design possibilities to make stuff like this cosplay armor plating, which is all done through a single form that was then offset and thickened and cut away, or stuff like this cutaway with these ribs and bosses and stuff that perfectly match the curved outer surface for an electronics case or something like that. So if you'd like to see even more advanced CAD tutorials or like a breakdown, like a project breakdown on why I did certain things, let me know. And any tips or tricks that you have that you use all the time in the surface modeling workflow, I'd love to hear it as well. And I'll catch you guys again very shortly here on Maker's Muse. Bye.